Hi, everyone. This is Venkatesh. I'm going to talk about Falcon, which is a new kid in the block in the Hadoop ecosystem. So I work at Hortonworks as both a software engineer and an architect. I have been contributing to Hadoop and its ecosystem, specifically Scoop, Oozie, Flume, mostly in the data management space for quite some time. So I'm a committer on both Falcon and Knox. Knox is the perimeter security. And have been part of the Hadoop team at Yahoo since 2007, working on data systems there. I've built a couple of generations of data management software, and Falcon is kind of built based on the learnings from Yahoo and other companies that we have been associated with. The agenda essentially will look at motivation behind Falcon, overview of what Falcon is at a high level. Look at we'll drill down into the architecture as to how things work underneath, and look at a couple of case studies. And if we find time, I should be able to also show a simple demo. This should look familiar to most of you, right? Who've worked with Hadoop or worked with big data systems. Typically, you have data sitting in your relational database systems or web logs or any other log sitting on some server. And the first thing you ought to do is to ingest this data or import this data from external systems into Hadoop for it to be useful, right? So that's the barrier to entry that we saw at Yahoo and typically at other enterprises. Because OLTP systems, give or take, is an RDBMS system, whether it's MySQL or Oracle. We used to have about 500 GB of data on a daily basis. Each table, you take dumps or you either ingest using Scoop row by row. Again, it depends on the use case and the volume of data. Then once you have acquired this data, you want to basically do some processing on it, right? You essentially express your pick scripts or Hive scripts or custom mapped use jobs, cascading, what have you, as a chain of a sequence of steps, either a single workflow or chained together as multiple workflows, right, producing multiple outputs. So you have some common patterns there, some common problems in data acquisition. And once you have either acquired raw data, and if it's financially critical, you have other facets like DR, right? You want to DR your raw data for disaster recovery or process data, because if your BI is pulling this data for reporting purposes, you may want to replicate this data across data centers. The other use case that we commonly see when you have a lot of data centers is you don't want to ship all your data from, let's say, one data center to another data center for aggregation purposes, right? So the classical use cases, if you have 4 or 5 or 6 data centers and you collect logs for that co-location, but you want to do some kind of aggregation across these data centers, right? So you typically do local aggregations, ship the local aggregates to your global data center, and then do a global aggregation across your local aggregates. So there also you need to replicate this data that was aggregated locally, right, to your global data center. So the other things are, once you have done your transformations, you may want to export this to a reporting tool for visualization. So you need some kind of export. And eviction is something we've seen. Even though you have petabytes of data, you quickly run out of space because you keep adding data. So you need some way of purging this data for capacity purposes. The second thing is for compliance purposes. If you have PII data, you want to make sure you don't have the PII information for more than 90 days. Typically, SOX mandates 90 days, and you can have anonymized data for however long you want. So the other thing is archival, right? Archival could be if you have on-prem, you can archive it into the cloud, or if you are in the cloud, you can archive it into something else, tapes maybe, or if you have multiple Hadoop clusters, you could archive into one of the storage-heavy Hadoop clusters itself into HDFS. So these are some of the common patterns that we see recurring in this Hadoop ecosystem. And some of the core services that kind of we saw were process management. So we'll get into more details, as we go further. But essentially, if you have multiple stages of your pipelines, you want to start your SLA-sensitive pipeline as soon as data becomes available. Most of the schedulers that we see are triggered by time, right? But in Hadoop, we want to see both time as well as availability of a partition either on a file system or in Hive. So as soon as certain partitions becomes available, I want to start doing roll-ups or some kind of aggregations. And I want some facility within the framework to say, I don't waste any time to trigger your pipeline, right? Late data. So there is always out-of-band data. There are some data that are machine-generated data that are not that critical, right? If you lose the last few minutes of data while you're processing, it's still okay. But if you're looking at financial information or auditable information, you want the close of books. And out-of-band data arriving after the close of books for that hour has to be accounted because this is something critical. So this is a common pattern that we saw at multiple places. The other thing is retries. So today, MapReduce provides retries, but it is built in, and if the task fails for more than 4 times, it just fails. There is no way for you to recover from it or configure that, right? So this is something we have, policy-driven retries. Very, very simple, but quite powerful. So coming to data management, again, I think I spoke about in the landscape, you want some kind of import and export because import is, data motion is a barrier to entry. So we need to provide some kind of facility where people can, ingest their data from external systems, replication and retention. Coming to data governance, as you run your processing, it can get extremely complicated. If you have, at Yahoo, we had about 700 stages of pipelines, right? So if something goes wrong, how do you re-trigger the processing? Do you continue from where you left off? Or, if you change the schema at the source, what is the impact of this change across your pipelines? Or you want to trace back to what the source was, for auditing purposes. So that is something, data governance, you want audit and lineage built into the system, kind of becomes a cross-cutting concern, which you don't want to, build it again and again with every pipeline that you design, and SLAs, of course. So these are some of the core services that kind of, stuck out and said, hey, why don't we take this out, which are mundane, and can be repeated again and again and provide this as a service, right? So this is how Falcon was born and said, hey, we can take all these tasks so that the user need not worry about doing these things which are necessary, but can be provided out of the box as a service, and the user could worry about deriving insights or working on how to actually understand the data and do some kind of analysis. So the core theme of Falcon is this holistic declaration of intent. So we wanted to provide users a way to express the things that we spoke about declaratively, right, and holistically, so that Falcon could understand what's going on across the system or across the pipelines for a given user. So data lifecycle is challenging, right? We have worked with, there are nuances with HDFS, there are technical challenges with different implementations, right? There is small file issues, right? If you have, let's say thousands of 1 KB files, you have namespace issues in HDFS, so you need to coalesce. If you have, large tar files, they are not splittable in HDFS, right? How do you split them? Because you'll start having long tails in MapReduce when you're processing them. So we have learned a lot of these things, while we implemented this or we looked at it, and kind of took all these learnings and put this into this package, right? So most of the things we spoke about, in the landscape can be done in a siloed approach, right? It's not that it cannot be done, but you'll start small and then suddenly you have 2 more consumers consuming that data that is generated. Then you start repeating, whatever you've written for different consumers. There can be upstream consumers, there can be downstream consumers. You can migrate your clusters from, one data center to another data center. You can start replicating this. So doing this, ad hoc is very, very hard and is error prone. So this is where Falcon comes in, and we'll dig into how this is achieved in Falcon. So at the core of Falcon, there are only three things. There's infrastructure, which could be your Hadoop clusters, your external database systems, your filers, your NAS, what have you. So this is infrastructure. Then we have data, which is on this infrastructure. We call them feeds or data sets, right? Your infrastructure could be your Hadoop cluster, an HBase cluster, what have you. And then you have this processing that is expressed on this data executed on a particular infrastructure, right? The process can consume, n number of inputs, can generate n number of outputs. These are feeds again, right? And this will be much more clearer when we look at an example here. So if you look at a cluster, right? A cluster, we call them entities in Falcon. A cluster essentially enumerates a bunch of interfaces. All it does is, what is my HFTP endpoint, right? I need HFTP endpoint for replicating this data, right? Because of version wire compatibility issues. HFTP or HTTP as well, right? What is my, it's a little off here, but the first one is, read-only interface. The write interface is HDFS, right? Read-only could be HTTP as well. Execute is my workflow. Execute is my job tracker or the resource manager, right, in Hadoop 2. So where do I launch my jobs, right, which the user has expressed? What is my workflow endpoint, which is Uzi here by default, right, in the Hadoop ecosystem? My registry is the HCatalog registry or Hive registry. Messaging, we use notifications. So JMS compliant messaging, you can plug in anything. Falcon distributes Apache ActiveMQ because it's open and Apache licensed. But you can substitute any JMS compliant message broker here. So this is the enumeration of a cluster, right? Very simple, few lines. All you need to know is what are the endpoints for different services in your cluster, and you enumerate that. And this is some housekeeping locations that Falcon generates. Falcon materializes workflows behind the scenes, distributes a bunch, like we spoke about replication, we spoke about retention. There are Java classes, jar files that are distributed in distributed cache for achieving those, right, out of the box. So these are kind of maintained here. So let's look at feed. It's few lines again. So this is very declarative if we look at it. You have a feed with a unique name, and you have a bunch of, you have a frequency. It could be an hourly feed, daily feed, a minutely feed, monthly feed, what have you. So we'll get to late arrival what it is in a bit. So you can also group a bunch of feeds together logically. For one is logical grouping. The second one is you can receive notifications as well. You can also associate tags. So tags are basically metadata. You can say this came from a Teradata database, or this came from my historical warehouse, or this came from wherever. And this is owned by somebody, published by somebody, consumed by someone else, whatever, it's open-ended tags. And you enumerate what clusters, right, this feed participates in. So this feed could be in cluster, primary cluster, and you could have some validity. And see, declaratively you're saying the limit is 2 days. That means you're enforcing a retention policy for this feed on this cluster. After 2 days, this data will be deleted. We support multiple policies as well, chmod, change owner, archive, what have you. So essentially, you're getting a lifecycle policy here by declaratively saying this is my retention, this is the limit, and this is the action. So if you can have many number of sources, many number of targets. If you have a source and a target, automatically it materializes a replication for you. So as soon as this data becomes available on primary cluster, this is copied to the secondary cluster. And the location is not burned in here, if you see. The location is all relative. So the locations in the bottom is common across all the clusters, but you can override this location per cluster, which is what is done for cluster secondary. And there is a retention limit of 7. That means you for the same data set, right, across your clusters, you can have different retention limits per cluster, right? So this is what we are saying. Now, if somebody is looking at this definition, now this feed or this data resides in n number of clusters, right? So if you can do multiple sources and one target with partitions, that means you can host let's say, search logs in one cluster. You can host, China logs in another cluster in another data center. And you can get all these different, market partitions into one global data center as well, that single target. Or you can do one source, multiple target. So you have, one-to-many replication as well. If you have a production cluster and, a research and a staging cluster, and you want this data on your, research and staging clusters, you can get that as well, right? So it's very open-ended, and you get a lot of things for free just declaratively by, specifying this. We also support ACLs. This is not the HDFS 2.0 ACL. We don't support that yet, but this is just the UGI we support. We enforce, who the owner is, who owns this feed, and what permissions, if the data is generated, what permissions would apply to that data. Any questions so far? Okay. Yeah. Yeah, yes. But it's extensible, right? I mean, we have added a database. I haven't shown it here, but we've added a database. So in database, it's very simple. The endpoint is going to be your JDBC, read-only endpoint, write endpoint, because you can't do anything else with a database, right? We don't execute queries typically. So for copying, for importing, we use read-only. When we export, we use write-only. Yeah. But you can create new entities as you go. It's open-ended. That's a very good question. We have done something similar at Yahoo, but no, we don't support it here, but it's extensible. So you want to basically say, based on the access frequency, I want to mark this as cold, right? Like if the access frequency is very high, 80% during the first 2 weeks, it's hot. After that, it becomes cold. I want to archive it. Something similar, right? Yeah. No, I mean, we don't support that today because we don't have the data mined in the backend where we can derive this access frequency. You know what I mean? You can extend. Yeah, you can extend it. Everything is interface driven, and when we cover the architecture, I'll go over. It's very simple to extend.
Is there something like a processing history possible that one data is derived from the other and you make a link?
Yes. Yeah, we're going to look at in the process definition. Yes. Cover this. So coming to process, right? So this is again pretty cool. So you have a list of clusters. So the fact that this process has one cluster means this process runs on that cluster. If you have one more cluster, you get hot. So that means this process now runs on 2 clusters or n number of clusters. I mean, think about doing this in a siloed approach, right? You have to take this configuration, burn in the cluster location, go register this in each of these different components across clusters. So here, Falcon does that automatically for you, right? And you have certain scheduling controls here. How much parallelism do you want, right? You can specify that here because if multiple partitions become available simultaneously, then you can run all of them in parallel, or we give different controls here: FIFO, LIFO, last only. If you're doing copy, right? You don't want to do it n number of times. Last only would suffice typically, right? Again, periodicity. So inputs is interesting. You can have n number of inputs here, and input essentially maps to a feed definition, right? Which has some lifecycle policy. So based on the availability of this input feeds, this process is triggered. And we also provide some cool, expression languages here. EL functions. So think about this, right? You may have an hourly feed, right? But you're doing daily rollups. So you want to consume last 24 hours of instances from the feed and do a rollup on a daily basis, right? So your process is daily, but your input for that feed is going to be the last 24 instances. So here you say today 0,24, it automatically picks up the last 24 instances, and then as soon as all the 24 instances becomes available, this process is triggered, right? And outputs essentially are created by this process, right? And we'll see what exactly does this process do. The process essentially executes a user workflow. A user workflow could be a simple pig. We support multiple engines, which are extensible again. We have pig. That means you just point to a pig script on HDFS or a Hive script with Hive engine, or you can have a complex DAG expressed in OZ today, right? We are planning to support Spring Batch and cascading pretty soon, but it's extensible. So we spoke about retry, here, but we're going to speak again in detail. So you can associate retries here. So if the process fails, right, what is my retry policy? It can be, periodic. It can be back off, exponential back off, things like that. And late processing, I'll come to it in a bit. So this is how simple, a process definition looks. So this is Falcon, right? So if user expresses a cluster, a bunch of feeds, and a bunch of processes, now Falcon knows holistically where all, which are data centers is this feed in, what are the lifecycle policies for this feed, and what processes use what feed and what is generated, right? So you can kind of know the dependencies up front very easily, and compute lineage at a course level as well as the fine instance level. Okay, so I think I briefly mentioned, what is late data, right? So in Falcon, each feed can define, what's the late cutoff, right? So I can have an hourly feed or a daily feed, but my late cutoff could be 6 hours or 3 hours based on the business that you are in, right? My events could be belong to the previous hour, but it can come 2 hours late for whatever reason, right? There was some problem, upstream, and it sent the data late. So you still want to consider that for the processing. So what Falcon does essentially is, as soon as it triggers the processing, right, it records the data set size. What was the size of this data when I started the processing, right? And after the cutoff, it recomputes the data to see if there is any change. Right? If there's any change, it now re-triggers the processing with the additional data. That means if you have a chain of processing, everything else is re-triggered in this chain, right? Automatically, without user intervention. So that is pretty cool. So in the process, instead of you have inputs, if one or more of them have late arrival metadata tag, you can define a late process and say, these are my late inputs, and you can also have an alternative workflow. So let's say you have done your workflow, but if it's late, you want to do only the delta, right? So you can specify that as a separate workflow. So there are different policies here: back off, exponential back off, and final. Final is it runs once and that's it, right? So retry we covered here. Essentially, back off and exponential back off are the two policies we support, and you can have some delay before the next execution of the workflow is retried. So this is something we did in the recent past, which I'm going to show. So this is how it looks. I mean, you can look at instances and click on an instance and then drill down from the right. So one with the gray is a terminal node, and you can keep drilling down to see. The blue is a process here, and green is a feed. So we see that there are two processes, or one process on the top generating one feed. These two feeds are input to another process, a joint process, which is generating another feed. Right. So in summary, it's a one-stop shop for data management. So it does multi-cluster management, data lifecycle management, process management, data governance. And it does not reinvent anything, right? It uses all the tools that are available in the Hadoop ecosystem. It uses OZ for scheduling. It uses DistCP for replication. It uses Scoop for database, import, export. It uses Hive and Pig. It doesn't reinvent any processing, right? People who, if you're familiar with, Pig or Hive, you can reuse that within Falcon and express that as a process. It just gives you a shell and a lot more of it for you to reuse. So any questions so far? Yes, sir.
What about error handling? Error handling?
What kind of error handling?
Like, let's say you're leveraging this CPU to do some replication, and then the CPU fails for some reason. Like how is that handled within Falcon?
So DCP executes as a map only job, right? So there is some kind of error handling in the sense if the task fails for whatever reason, it retry, and then you have retry policies here as well. So it is retried 3 times implicitly in replication.
You have a kind of possibility for workflow definition in Falcon as well.
Yeah, the user workflow, yeah.
The user workflow, so you have a nested workflow. So you can use, of course, OSI within the workflow and OSI within the OSI stuff.
Yes.
You said you don't reinvent, but in some sense you reinvent.
No, we are not reinventing. We are essentially taking a user's workflow and creating a sub-workflow of it and decorating that workflow definition with some pre-processing and some post-processing. Like I told about late data handling, right? We record the input data. That's a pre-processing, right? In the post-processing, we just send notifications for re-triggering, retries or, basically late data handling as well. Once the late data cutoff is reached, we recompute the data. And then, so it's essentially the workflow definition is decorated, that's all. We don't create a new workflow execution system. We use UZI as the workflow execution system, execution engine. Falcon is a very thin veneer which sits on top of, UZI. Yeah, which is what this is, right? Falcon essentially doesn't do any heavy lifting, right? All it does is provides you a higher layer of abstraction to express whatever you're doing, but provides you out-of-the-box services, declaratively. And you basically, it provides both CLI and REST API. CLI is essentially a wrapper over REST API. So you can submit all your entities, which is your infrastructure, your data, and processing. Falcon essentially takes this, and once you schedule them, it materializes workflows in OSI. Also, it stores the user configuration on HDFS, right? I mean, it can store on local file system too, but preferably on HDFS because of availability. So even if Falcon goes down, it comes back up, by reading user configuration or these entities from HDFS. All the workflows are materialized in OSI, right? And workflows that depend on both HDFS or Hive tables are materialized in OSI as well, right? And if you have expressed feeds that are Hive tables, it talks to HCatalog. Otherwise, you can inquire into the status with Apache Falcon, with Falcon. Falcon goes to OSI and fetches the statuses for you, right? So it doesn't have any persistent state or in-memory state in itself. So it's very, very lightweight, right? And it also uses messaging for communicating, the workflow status, whether it failed for retries, whether it completed, things like that into Falcon, as well as provides notifications for users. So it publishes topics based on the names of the feeds or processes, right? So users can now get notified, for if you listen to that topic, which is, missing in the Hadoop ecosystem, right? So it's both for user notification as well as Falcon itself uses JMS to receive notification workflow job end notifications. So let's see how a feed is materialized, right? So you have, of course, you need to have a cluster or a set of clusters, and you provide a feed definition into Falcon. So the first thing that happens is, this is stored into the config store on HDFS, and every feed for a cluster, there is a retention policy, right? That means for every cluster, there is some kind of eviction policy, and that is materialized as a workflow within OSI, right? Second thing, if you have more than one cluster with source and target tags, then a replication workflow is materialized, right? So Falcon materializes workflows and schedules them in OSI, right? And a process is very similar. Like here, the user workflow is decorated with some pre- and post-processing, and that workflow is materialized in OSI scheduler as well for each cluster, essentially. And from a physical architecture perspective, Falcon is one per data center. Typically, almost all of the components are one per Hadoop cluster. So you could potentially have multiple Hadoop clusters deployed within a data center, right? You can have one production, one research, right? In that case, like I was talking about the local global aggregations as well. So you need only one instance of Falcon per data center. And if you have more than one data center, which involves multi-cluster processing, then we have something called Prism, Falcon Prism server, which is essentially acts as a gateway. So you submit your entity definitions to Prism, and Prism just forwards it to multiple Falcon servers. So we support standalone, which is the most typically what is used, which is an embedded. Everything is embedded, and when you run one Falcon server, it does everything. It's just that if you have more than two sites where you're doing distributed processing, it's better to have Falcon in distributed mode. So let's look at a simple case study here. So you have stage data, which is essentially raw, and you want to replicate this across two clusters. You run through a processing to cleanse the data, and then have some intermediate form, and then have presented data, which is again replicated so that it can be consumed by a BI or analytics application. So again, Falcon manages workflows, replication, and retention. And you have one feed definition or two feed definitions here, which is one is for stage data with two clusters, and presented data with two clusters. So automatically you get replication. And you'll have some script, pig or hive, which consumes stage data and creates presented data. And you can also express them as intermediate data as feeds with different retention policies. This is the one case study that is used at InmoBee, which is what Falcon initially was built. So you have your ad requests coming in, impression clicks, and conversion events coming in to a single data center. You want to do some kind of aggregation here, right? Some kind of enrichment and aggregations on an hourly basis. So you do this in one data center, right? And then you will have a single hourly feed for the summary with one per data center. That means you'll have multiple clusters within the same feed definition, right? And here you have minutely feeds with identical location, right? And retention configuration with many clusters there for each data center, right? And your global aggregation essentially is that same feed of the summarizer, right? Or summary feed across these data centers, and you create another process, which is this becomes the input for the global aggregation process, right? And you have the global aggregated data as the output of that process. So it's very, very trivial to express complex processing which spans multiple clusters and colos in Falcon. Okay, so we've just added lineage, which is still in the works. We want to add audit compliance as well, and we will also provide some kind of data masking, because a lot of this is a common task, right? You have some PII information, you want to anonymize that, right? It's a one-way hash. So you can customize it or use, specify a column and say, this is social security number, or this is the credit card information. Give me a one-way hash of this, right? Or IP address, what have you. So these are some of the things we want to provide as reusable components as part of Falcon, so that people can use them as a service. We're also building Data Pipeline Designer, which is a visual way of building a process. That means you don't work with the process definitions, but you have some kind of filter, project, aggregate. You drag and drop, and behind the scenes it creates a pick script essentially. So this is in the works. We're also, data acquisition is largely missing. We have database-based data acquisition, but we don't have file-based. Because it's very hard to develop connectors for 400 different systems. So almost all the systems are really good at dumping data and importing data, right? You can take Teradata, they have fast import, fast export. You have Oracle, your CRM. Oracle has its SQL loader, which is super fast, right? So we want to basically dump data to a NAS and have Falcon pick up files based on a NAS and export data to a NAS. So that it kind of covers 80% of the use cases. And have a monitoring management dashboard and some kind of SLA monitoring as well. Okay. Any questions? Well. That's a very good question. There has been talk in the community. In fact, InMobi, he's here actually. Sharad is here from InMobi. We are talking about having streams as just like we have feed, which is batch oriented. We'll have a streams entity, right, which represents a stream, and have a process consume streams and generate some kind of a topology in Storm, right? So we are evaluating that, and we will definitely have that integration for sure.
How would you compare it to something like Spring XD? How would you compare Falcon to like Spring XD?
I don't know about Spring XD. I know Spring Data a little bit. So Spring is more like gives you a way to launch a Hadoop job using Spring kind of Spring framework, but doesn't alleviate you from actually hardwiring things into the Spring itself, right? Can it?
XD is more about data processing and it's
But does it do lifecycle management, replication, retention? Does it do even? Does it do even relays, process relays? As soon as data becomes available, scheduling this process. I don't know. Yeah, I don't know about Spring XD. Okay, I have a VM running locally, which is Hadoop Sandbox. So we have a very simple UI. What feeds? I have clicks, impressions, and a join of this is clicked impressions. So I have a. Oh really? Sorry. I need help. It's not. Oh, it's. I need to go back to displays. This is not showing up. Okay, I'm a little challenged here. Okay. So I was saying we have a very simple dashboard where it displays a bunch of clusters. You click on it, it gives you the definition of the cluster data sets. I have clicks feed, impressions feed, and a join of this clicked impressions feed. Right? I mean, I don't have any replication, so it doesn't show, but it also shows the dependency here. It shows a graph of all the dependencies you can look at based on what Falcon maintains. So there are, again, there is a clicks ingest process which ingests the clicks data, impressions ingest, and then there is a join process. Right? So if you look at it, you have multiple instances. This is an hourly feed. So 318.00, 01 and 02, it's running. So if you look at the lineage here, this is what I was talking about. This is a feed. So the metadata tags that I showed you are all captured, and those relationships are displayed here. This is a process. You have the user workflow name, the user workflow engine, what it was. If you change it, the lineage captures the history for that particular instance, who the owner is, which cluster did it run on. So if you migrate this to some other cluster, it'll capture that information for that particular instance. So this is the feed. If you double click, it says this is the process that generated this feed. Here, this clicks ingest is what generated this clicks feed here, right? So this is lineage. So if you look at it, I mean, it's pretty simple, right? This is the definition here, few lines, but the same thing materialized in OZ, right? Let's look at this join process, right? And job definition. It runs to pages, literally, right? So, you don't have to hardwire all this, 100 or 200 lines of XML in OZ, debug the problems. There are a lot of nuances as well. So let's say you update your feed definition to run on a different cluster. That means you need to turn off or terminate the coordinator, restart something else right away. So doing all this is, cumbersome, error-prone. So the framework already gives you these different things and kind of lifts you to work with higher layer of abstraction without worrying about files, directories, schedules, right? So you work with these entities at a higher level. Yeah.
It means Falcon is basically a user interface for OZ, not only, but this as well.
It's not a user interface, right? It's much more than that. You get all this lifecycle. Yeah, you have out-of-the-box services that are provided to you declaratively so that you can express them declaratively and you have that as a service available to you. The only thing is all these are materialized in OZ and nothing is stopping you from actually orchestrating this in some other workflow engine, right? So you could, potentially turn it into Azkaban workflow as well, right? I mean, there's nothing stopping you. All you have to do is the workflow mapping that you need to write, right? So
there are specialized vendors on lineage right now.
yeah.
They have more advanced.
Of course, yeah.
What are your plans of
So our mantra is, crawl, walk, run. So we're crawling right now. So of course, yeah. I mean, Informatica, data stage, IBM data stage, yeah, they have pretty sophisticated stuff. Yeah, we've started small just to show, drilling down. We haven't done impact analysis. We will see. Yeah.
You have users of this right now, right?
Yeah, that's the reason we are developing it. But yeah, I mean, I've seen other products as well, like Loom and stuff. It doesn't do beyond this. So we will see as and when, if the need arises, we will add it. Plus, it's open source. I mean, people are free to contribute as well.
Do you have dates around some of those features that you're planning?
I mean, we have all this committed. There is no release yet of these things. So this is what we are debating in the open source, right? I mean, some people want a release for all the stable features. But I'm arguing, we can have certain features that are stable, certain features that are, experimental or alpha and still have a release. So we're still debating. But some of the features, like I didn't talk about security. It's now Kerberized completely. We support Kerberos and SSL now. Windows support is coming, which is part of HTTP. So we are GAing that in 2.1. Yes, it's already committed. As I said, there is no release yet for Kerberos, but it's committed in trunk. We will pretty soon have a release which will cover security, lineage. Hive integration is also done. So you can express feeds that I showed as location on HDFS. Instead, you can just say, a URI which says, this is my database, this is my table, and these are the partitions. Yeah, that's already supported. No, we're because it's kind of popular. It's cascading, so we want to do it.
What about the monitoring dashboard?
I showed you it's pretty simple, but now that we also have another cool thing, of course, only with HTTP is Ambari. Ambari now installs Falcon. So as part of that, we will have a good dashboard as well. Yeah.
Is this like 2.1? Is part of 2.1?
Yeah, 2.1, yes.
Does it work with multiple clusters of CDH and multiverse?
It should, yeah. Okay, thank you, guys.